today most of the students, they feel rather difficult to memorize the how to memorize this derivations. According to me, there is no need of derivations. There is no need of memorizing these derivations. If you have a good knowledge of the picture and the formulas and the theory, you can derive it yourself. So let us see a simple example. This I have done to clarify the students that they feel rather difficult to memorize the derivations. There is no need to memorize these derivations. Here you see, let us take an example. The electric field produced by a dipole. Let us take a electric field produced by a dipole. This is a dipole. Electric field produced by a dipole at some point P here. At some point P. Electric field produced with this dipole. This is Q and this is minus. So here, this is the center of the dipole, and so here A length is 2A, and your dipole moment is in the direction from negative to positive. So we have to find out what will be the electric field at point P. What will be the electric field at point P? So let this be R1 and this be R2, and here this is R. It is making an angle theta here. So here, first of all, you know that you think yourself how to derive this, that what will be the electric field at point P. Now, you first of all you think like this. What will be the potential? Means you have to derive the potential. What will be the potential? Sorry, not electric field, potential at point P. If you want to derive what will be the electric potential at point P due to a dipole. So you draw this figure, and you know that what will be the potential at P because of the Q. So potential at P will be your K Q by R1. You know that the potential here will be K Q by R1 because of Q. And again, what will be the potential at P because of minus Q, and this will be K minus Q by R2. So what will be your total potential at P? So your total potential at P will be K Q R1 minus K Q R2. This will be your total potential. So K Q 1 by R1 minus 1 by R2. This is your main first step you have to do. So here there is no need of memorizing it, because you know the formula for potential. What is the potential at point P due to Q, you know that. So you can easily put these values, and your total potential will be this much. Now here little bit mathematics you have to do, because here there is a cosine rule, that is R1 square is equal to A square plus R square plus 2AR cos theta here. Now for here, what you are going to do, you take this R square common. So R1 square is equal to, if you take R square common, this will be A square by R square plus 1 plus 2A. Because you are taking R common, so this will be R square, so this will be cos theta by R. So this is your. Now since A is very small, so A by R square, this you can neglect it, this ratio you can neglect it. So here you will be R1 square is equal to R square, this will be 1 plus 2A cos theta by R, this will be your R1. So here your R1 will be R root over, that is 1 plus 2A cos theta by R. This will be your R1. Here this will be your R1. So here you see you have found the formula R1. Now we are going for R2. Your R2 square, that will be equal to, again we have to apply cosine rule. This will be 180 degree minus theta. So R2 square, this will be again your cosine rule, a square plus r2, this is r square plus 2a r cos 180 degree minus pi minus theta. This is pi minus theta. So this comes out to be r2 square. That will be, again you are taking r square common, that is a square by r square, that is plus 1 plus 1, and here this will be minus 2a cos theta by r. This now, because we are going to neglect this a square by r because a is very small, you know about the dipole. So here r2 square, your r2 square will be r square, and this will be 1 minus 2a cos theta by r. So this will be cos theta by r. Now here if you take value of r2 taking square root, this will be 1 minus 2a cos theta by r. This will be your 1 by 2, this will be your value. Now just you have to put the value of r1 and r2 here. So your potential will be V is equal to this kq. You place here 1 by r1. This is this one. So this comes out to be r 1 plus 2a cos theta by r to the power of half, and here again minus 1 by r 1 plus 2a cos theta by r to the power of minus half. This you are sorry, not minus half, plus half, plus half. This is plus half, plus half. This you are going to get. Now you do like this, that is V is equal to kq by r. This is common. So here 1 plus 2a cos theta by r to the power of minus half minus 1, this is minus, sorry, this is minus 1 minus 1 minus 2a cos theta by r to the power of minus half. So now I am going to use binomial expansion. When you use the binomial expansion, you are going to get kq by r. This is 1 plus this is minus, this will be minus half into this, minus half into this, half into 2a cos theta by r. I am going to neglect the higher values because they will be very small, so we are going to neglect it. And now this minus, this will be again 1 plus 1 by 2, 1 by 2 2a cos theta by r. So here we are going to neglect the higher values because they will be very small. So here your V will be equal to kq by r. 2 cancels out. Now if you solve it, this is you are going to get this 2a cos theta by r. You are going to get 2 cos theta by r. So here 2a cos theta by r, you are going to get this. Now here you know that 2aq, it is the dipole moment. So this is k by this is r square, and here this is the dipole moment p cos theta. This is p cos theta. This is your dipole moment. So here what you are going to do, this is your 2aq, this is your dipole moment. Now you move this cos, you move this, that will be dot product, that will be k p dot r cap by r square. So here again you this k value 1 by 4 pi epsilon naught p dot r r cap, sorry, this is r cap, unit vector, by r square. So here you will see that you got the potential at point P because of this diagram. So here you say this is very easy. You need not have to memorize. Only there is some mathematics which is binomial theorem, and other the main theory lies here, and you can easily calculate it. So here This is the potential at point P due to the dipole. Now, again, I want to show you one more thing, that is here, one more thing, that is now, similarly, if you want to derive what is the work done when a dipole is placed in an electric field. Work done, what is the work done when a dipole is placed in an electric field? What is the work done? You want to calculate it. So this is your dipole, and dipole, this is plus Q, this is minus Q. So here you see that, and this is theta. So here you see that the net force, the most important thing here you must remember, that is your net force. Net force. Your net force is zero. Your net force is, this is very important. The net force is zero. Only the electric field will try to rotate the dipole either in the either parallel to the electric field or anti-parallel to the electric field. This you must remember, that the net force will be zero, and net force will be zero, and the external electric field, this will try to rotate the dipole either in parallel to the electric field or anti-parallel to the electric field. Means this electric field creates a turn, and this turn you must remember, that is dipole moment cross E. This is your turn. This you must remember. This is the turn. Now, so the work done, what will be the work done? Work done, that is the your dW. Work done, that is will be turn dot d theta. This will be your work done. Turn, this will be your, this is your turn. I have written all this in scalar form because we are going to derive the work done magnitude. So here dW, what is dW? Because it is a cross product, so this will be dE sine theta d theta. This will be dE sine theta d. So if you want to rotate it from theta naught to theta 1, if you want to rotate it from theta naught to theta 1, so your total work done will be equal to your dE, that is theta naught to theta 1. Theta 1 sine theta d theta. This is true. And when you integrate it, your work done, this will be dE, that is minus cos theta, and your here upper limit minus lower limit. When you do this, you are going to get W is equal to dE, that is cos theta naught minus cos theta 1. This you are going to get. This is what you are going to get, that is about the work done. So now if we initially consider theta naught, theta naught to be pi by 2 and theta 1 to be theta, so your work done will be equal to W will be PE, that is cos 90 degree minus cos theta. So here this 90 degree is 0, so your work done comes out to minus PE cos theta. So this will be a dot product because it is a scalar quantity, E vector dot in E vector. So this is the work done by the external electric field. So see, there is no need for memorizing it, only the concept and the theory must be clear to you. That is, what is the concept? That is, the concept is when a dipole is placed in an external electric field, when a dipole is placed in an external electric field, your net force is zero. Only the external electric field will rotate it either parallel to the electric field or anti-parallel to the electric field. So rotation, so electric field is creating a turn, and when it is creating a turn, so there is a work done. So this is your work done, and in this way you can derive the formula. Now again, I want to show you, this is about electric fields. Now similarly for magnetic field, suppose for magnetic field, that is Here you consider a circular loop. Yes, this is a circular loop, and here you consider this is a circular loop. This is your x, this is your z, and this is your y. And here you are considering a small element dl, and current is flowing through it, small element dl. Now you have to find what will be the magnetic field, what will be the magnetic field at some point p here, what will be the magnetic field at some point p. So here the most main concept that you must remember, that in any formula where there is magnetic field, in any formula where there is a magnetic field, it is always, any formula which deals with magnetic field, it is a cross product. Any formula which deals with magnetic field, it is a cross product. So it will be in 3D, always it will be in 3D, and there will be planes, because here there will be planes, different planes. This is the main base concept, that whatever be the formula, if in the formula it is magnetic field, then it will be always cross product, and for cross product we require different planes. For cross product we require different planes. This is the main base. So if your current carrying loop, this is the current carrying loop, your current carrying loop is in YZ, current is in YZ plane, if this is in YZ plane, so your magnetic field will be in another plane perpendicular to this plane. Magnetic field will be in another plane, and your magnetic field will be in this is XZ plane. Your magnetic field will be in XZ plane. This is the most basic concept. This is the most basic concept with magnetic field. So here you see that whichever be the formula, if there is a magnetic field, it will be always cross product, and when there is a cross product, so here you will find that it requires different planes. So if your current carrying loop is in XY plane, then automatically your magnetic field will be in another plane, and that is considered as an XZ plane. So here at a distance from the center, let us take this as X, and from here let this distance be your R, and this is the radius of the loop. And now this is the radius of the loop. So you have to find the magnetic field at point P. Here the magnetic field, because it is in the XY plane, and this magnetic field exact plane, this is the exact plane. So your magnetic field this is magnetic field making some angle theta with the x-axis. So it has two components. One is perpendicular component, and another is the parallel to x-axis, that is the parallel to x-axis. This is the x component. So here what happens, because of this dl, because if you consider dl, here again there will be a magnetic field in the opposite direction to the perpendicular. So this cancels out, only this magnetic field remains here. Now here we are going to use Biot-Savart law. So according to Biot-Savart law, the magnetic field at dB, that will be dB is equal to mu naught by 4 pi I dl sine theta by r square. This will be your magnetic field at point P. So this is the Biot-Savart law, you must remember. Now only the thing is that whenever there is magnetic field, they will be in different planes, and if this is in YZ plane, your magnetic field will be in XY plane, and so here the P point, at P point this dB is making an angle theta with the x-axis, and here now here since your dl are r sine theta. Now here since your dl and r, they are all, again they are in different planes, because dl is in yz plane and your this will be r vector will be in xy plane. So these two planes are making 90 degree. So your theta will be 90 degree. So dB will be equal to your dB will be mu naught by 4 pi I dl sine 90 is 1. So this will be your r square. Here this will be your r square. Now here this r dl sine theta now here, because the magnetic field will be along your magnetic field will be along x-axis, so your dB, this dB will be equal to dB cos theta, because it is along x-axis, along x-axis, so this will be dB cos theta. So this comes out to be mu naught 4 pi, we have 4 pi I dl cos theta by r square. This comes out to this. What is your r square? Your r square is x square plus r capital R square mu naught by 4 pi I dl, and what is your cos theta, and your r is this is r square plus x square. This is your r square plus x square, from because we are going to get this from the Pythagoras theorem. Now what is cos theta? This is also cos theta. This angle will be same here. And this cos theta, what is this cos theta? Your cos theta will be based by hypotenuse, so this will be r by root over r square plus x square. So here this comes out to be mu naught by 4 pi I dl, your cos theta, that is r, and here this becomes r square plus x square 3 by 3. This comes out to be this. So this is the magnetic field we are going to get here. So this is for the small element. If you want to find Px for the whole loop, so it will be this dl will be 2 pi r. Now this dl will be this is your magnetic field at this magnetic field dx. Now here we if you want this is your, if you want the what will be the magnetic field at the center. So if you want the magnetic field at the center, B naught, dB naught, magnetic field at the center, what is the magnetic field at the center? So the magnetic field at the center, your x will be 0, so 3 cancels out, 3 square, so this will be equal to mu naught by 4 pi I dl, this will be your 3 then again r square, this will be your r square, this will be r square. So for magnetic field at the center, because of this whole loop, this will be V naught, that is mu naught by 4 pi I, and dl, that will be 2 pi r. So this will be, this cancels out, so r1 cancels out, so this will be mu naught I by twice r. So this is the magnetic field at this center, mu naught I by 2r. This is the magnetic field at the center. So this is how you can calculate the that means you can derive the magnetic field at the P or magnetic field at the center. So this is how the derivations are done. So the main object is your figure must be clear and your formulas, that means your formulas must be clear. Then you can easily derive the required whichever you want, you can easily derive it.